For most people, the internet feels like a completely open and decentralized system. Anyone can create a website, upload videos, send messages across the world, and connect with people thousands of kilometers away. Because of this openness, many users assume that the internet is controlled by no one. A vast digital environment where information flows freely across networks without a central authority. But behind the familiar websites and apps people use every day lies a physical infrastructure that is far from decentralized. Beneath oceans, across continents, and inside massive data centers exists a network of cables, routers, servers, and exchange points operated by a relatively small number of organizations. These companies and institutions manage the infrastructure that allows data to move across the global internet. To understand how this system works, it is necessary to examine what engineers call the internet backbone. The backbone refers to the core networks that connect major internet service providers, data centers, and global communication routes. Whenever a user opens a website or sends a message online, the data must travel through multiple networks before reaching its destination. Each network represents a segment of the global internet operated by a particular organization. Some networks belong to telecommunications companies that provide connectivity between cities and countries. Others belong to technology companies operating massive cloud computing infrastructures. Together, these networks form a complex web of interconnected systems that carry global internet traffic. One of the most important components of this infrastructure is the system of submarine fiber optic cables. Although wireless technologies such as Wi-Fi and cellular networks connect devices locally, most international internet traffic travels through physical cables laid across the ocean floor. These submarine cables stretch for thousands of kilometers and connect continents together. Signals travel through these cables as pulses of light inside extremely thin strands of glass, known as fiber optics. Each cable can carry enormous volumes of data, supporting communications between countries and regions around the world. Building these cables requires significant investment and engineering expertise. As a result, the number of organizations capable of constructing and maintaining global cable networks is relatively small. Historically, submarine cable systems were operated primarily by telecommunications companies. Organizations such as AT&T Verizon and international telecom providers built networks connecting major population centers. However, over the past decade, large technology companies have also become major investors in global internet infrastructure. Companies such as Google, Meta, Microsoft, and Amazon now finance and operate their own submarine cable systems. These investments allow them to connect their global data centers directly and move enormous volumes of data across their platforms. Another critical component of the internet infrastructure is the network of data centers distributed around the world. Data centers are facilities that house the servers responsible for storing and delivering digital content. Whenever someone streams a video, opens a website, or sends an email, the information must be retrieved from servers located inside these facilities. Some of the largest data centers contain tens of thousands of servers operating simultaneously. They require sophisticated cooling systems, high-capacity power supplies, and high-speed networking equipment to function reliably. Major cloud providers such as Amazon Web Services, Microsoft Azure, and Google Cloud operate enormous global networks of data centers. These facilities host applications, websites, artificial intelligence systems, and many other services used by businesses and individuals. Because so many online services rely on cloud infrastructure, the companies operating these data centers play an important role in the functioning of the internet. Beyond cables and data centers, another crucial element of internet infrastructure is the system of internet exchange points. Internet exchange points, often abbreviated as IXPs, are physical locations where different networks connect and exchange traffic directly. At these facilities, multiple network operators place routers and establish connections with one another. This allows data to travel between networks without passing through unnecessary intermediaries. Internet exchange points help improve efficiency and reduce the cost of moving data across networks. Some of the largest exchange points handle enormous volumes of traffic every second. They function as central hubs where networks interconnect to form the global internet. Although the internet operates as a decentralized system of networks, The companies that manage large infrastructure components often carry significant influence. Organizations that control major fiber routes, data centers, and exchange facilities play a central role in determining how data flows across the internet. Routing decisions made by network operators influence the paths data packets take between different locations. While no single entity controls the entire internet, the organizations operating large networks collectively shape the structure of global connectivity. In recent years, the scale of internet infrastructure has expanded dramatically. The growth of cloud computing, video streaming, artificial intelligence, and digital services has increased demand for network capacity. New submarine cables are being constructed to handle growing data traffic between continents. Large technology companies continue building additional data centers to support expanding online platforms. At the same time, the geopolitical importance of digital infrastructure has become increasingly clear. Governments recognize that communication networks, cloud services, and internet infrastructure are essential components of modern economies. As a result, many countries have begun investing in domestic internet infrastructure and cybersecurity capabilities. These developments illustrate how the internet has evolved from a research network into a critical global system supporting commerce, communication, and information exchange. Yet despite its enormous scale, the infrastructure behind the internet remains largely invisible to most users. People experience the internet through apps, websites, and digital services without seeing the cables, routers, and facilities that make those services possible. Behind every message sent, every video streamed, and every website opened lies a vast network of physical systems connecting the world. And while the internet may feel like an abstract digital space, it ultimately depends on real infrastructure operated by real organizations. Companies that build networks, operate data centers, and manage global connectivity quietly power the digital world. Because in the end, the internet is not just software and information. It is a physical system built by engineers, maintained by infrastructure companies, and operated by networks that span the entire planet.